Welcome everyone to our talk about simplifying network automation with NetBox Operator, or how we call it, just claim it. Very excited to do this. I'm Joel Studler. I'm a DevOps engineer at Swisscom. I'm here with Brühwiler, DevOps engineer in the very same team. We both work for Swisscom. Swisscom is a major Swiss service provider for IT and telecommunication services. We both work in the 5G core automation team to automate the 5G deployment and to really modernize this entire ecosystem. So for us, this is mainly about moving from a legacy telco to a more modern techco. This includes like getting rid of Excel spreadsheets for configuration, getting rid of manual work, really trying to automate as many things as possible. And we really think that we can do that using Kubernetes, using GitOps, and so on. So let's start with where we're at today, or where we were a few months ago. This is your average configuration manifest in a 5G core. It's an XML file. It contains a lot of nitty-gritty details that you check into Git, and then you try to somehow manage that, right? So it's a rather static configuration which contains all the low-level details like VLAN IDs, IP addresses, and so on. And you need to provide that in advance. So we were thinking, what if we could move to a more dynamic approach, more dynamic configuration, which would start with a high-level intent, which contains only the necessary information you need, and then you have a system that surrounds it, which is able to actually figure out all the details on its own. So that would be a rather dynamic approach, and we think for us that's about adopting the Kubernetes resource model. We really think that KRM can help us on achieving that. So as a reminder, Kubernetes resource model contains of the CRD extensions, basically API extensions of the Kubernetes API. It contains custom resources as instances of these CRDs. And then lastly, you add your business logic where you can do whatever you needed to do in the end. So Kubernetes resource model is one piece of the puzzle. The other piece of the puzzle that I would like to talk about is the claim approach, which is concept that we see in Kubernetes already as of today, which basically splits the source of truth from between Git and Kubernetes. I'm showing you this based on the example of a persistent volume in Kubernetes. So it usually starts with a stateful set. You create a stateful set in Kubernetes, and there you define, for instance, you want a 1 gigabyte volume in the end. And that's all you need to tell the system in order to make it work. This will then be synced to the Kubernetes API using GitOps, hopefully. The stateful set controller will take over and reconcile it, create the persistent volume claim. Then you will have the persistent volume controller doing its magic, and eventually you will have a running pod which has a 1 gigabyte interface attached. That's just an example to show you what we did in NetBox Operator. And you can see it's a very dynamic system. You only give it the necessary information that is required at the beginning. If you look at that same example from a source of truth point of view, we can see in Git, we only have the stateful set and the very high-level intent. We sync that to the Kubernetes cluster. There we have an exact copy of this object, and we have an additional information like the PVC itself, the PV, which contains some ID that you don't want to know in the end as a user, and the pod. So in this example, you can see we already have a split source of truth between Git, which contains only the high-level idea of what you're doing, and Kubernetes. So with that, I hand over to you, Lea.
Thank you, Joel. So if we compare pure GitOps with GitOps combined with KRM, the PVC example showed well how the source of truth is shared between Git and Kubernetes. So this allows for abstraction In Git, you only need to store your intent, and the details can then be handled by Kubernetes. This also gives you flexibility, as you don't know all the details in advance, but some things can be calculated at runtime. It also makes scalability easier, as you can just claim more things, more instances of the same thing. And it also reduced the operational complexity. So you saw the big configuration in the beginning. If you look at it like at a monolith, you could compare GitOps with KRM to a microservice. And one of these, if you look at it this way, one of these microservices would then be NetBox Operator, which would handle the IP address management. So if you'd like to learn more about our journey from GitOps to KRM, I'd like to recommend the following talks by my colleagues from Swisscom. So at the end of the presentation, there will be a QR code where you can find the slides, and you can open the links from there. I'd like to give a short introduction about NetBox. So NetBox is an open source tool for network element and IP address management. It offers a comprehensive API which you can use for automations of your, for example, cables and racks, or also IP addresses. The NetBox Operator is a Kubernetes operator we built in Swisscom and open sourced, and it makes these resources directly available in your Kubernetes cluster. So it uses NetBox as source of truth, and it also has some advanced features like steep key IPs. Currently, IP addresses, IP ranges, and prefixes are supported with NetBox Operator. And it's based on the claim model, similar to the persistent volume claim we showed before. So with NetBox Operator, you can define claim resources, for example, a prefix claim, which will then, with GitOps, be applied to your Kube API. And then the prefix claim resource will communicate to NetBox to find a prefix. Then the prefix will be created on your cluster, and the prefix controller will then create, update, or delete the prefix in NetBox. So if you look at the source of truth here, the intent is stored in NetBox or in Git, and then when it's applied to the cluster at runtime, you will get the prefix that's actually used. So now I want to show NetBox Operator in action. So I've set up a local kind cluster, and there I have a NetBox instance installed and also the NetBox Operator. And then I'll apply a prefix claim custom resource, which will then be reconciled by NetBox Operator. You'll also be able to find these examples in GitHub if you want to try it out yourself, with instructions on how to set up a local kind cluster. And I've already done this now. So for these demos, I assume that I can use any prefix which is in NetBox and has the custom field environment set to prod. So I create one prefix now. And here I'll define the custom field. So most likely, if you would use NetBox Operator, the prefixes are already present in NetBox. And for this demo, I created it now. So So let's have a look at how the prefix claim custom resource look. So here you can see we defined a tenant. This will be the tenant of the claimed prefix, the parent prefix we created before, and also the prefix length we want to get. If I now apply this to my Kubernetes cluster and list the prefix claim and prefix custom resources, we can see that the first three prefix in that parent prefix got assigned. All right, so in our case, we're not limited to that one prefix, but we can use any prefix that has the custom build environment set to prod. For this, we have a dynamic version of this prefix claim, which will filter the prefixes in NetBox based on custom fields. So here, the NetBox operator will first do the filters of the possible parent prefixes, then it will select one and assign a prefix from there. So this is the manifest we'll use. So instead of a fixed parent prefix, we have now a filter for the custom field environment set to prod, and also IP family IPv4. So I apply this to my cluster now, and I list again the prefix claim and prefix custom resources. So we got a second prefix assigned. So now, how can we then use the claimed prefixes on our clusters? For this, I would like to show an example where we do a load balancer configuration with the claimed prefix. This means we somehow need to map the status field prefix from the prefix claim to the custom resource that's used to configure the load balancer. In our case, we'll use Kero for this demo. Kero is a tool where you can define mappings between fields of different CRDs. And I've already installed Kero and this mapping on my Kind cluster. So you can see again how the prefix is mapped to the MetalLB IP address pool. And then we'll be able to get IP addresses from this pool assigned to our services. So here for this example, you'll also need MetalLB and Kero installed on your Kind cluster. And you'll find information on how to set this up in the README. So here in this manifest, you'll find all the information requirements required for this mapping to create the prefix claim and the MetalLB IP address pool. And so let's check which prefix we got assigned and how the MetalLB IP address pool looks like. So, right. I need to move this around so we can see the entire width of the terminal. So here we can see the new prefix that was assigned, and the MetalLB IP address pool has the same one. So now I'd like to create a sample deployment. I create the nginx deployment, and here I only need to set this annotation to define which MetalLB IP address pool to use. And I use type load balancer. So I apply this to my cluster, and now I can list the deployments and services in the namespace that got created. And we see that we got an external IP assigned. So now we can also access our deployment over this IP. So you could also define other mappings to use these prefix claims for other configurations, for example, a CNF configuration. With this, I'd like to hand over to Joel for more demos.
Thanks a lot, Lea. So I'm going to show a last use case or last demo, which is the restoration of prefixes. In this example, we create 3 different prefixes. We let them reconcile, so they're healthy, and we have the prefix. Then we will remove them in Kubernetes and recreate them and make sure that we get the same IP. So that's one of the features of NetBox Operator, to actually allow you to restore the prefixes based on the external source, which in this case is NetBox. So for that, I will first create a new namespace called restoration. That's just for the sake of the example. And I will create 3 different prefixes. If we look at one of these YAMLs, we can see it's similar to what Lea showed earlier. It's basically based on a parent prefix selector. We create a new prefix. You can see there is this preserve in NetBox flag set to true, which basically tells NetBox Operator if the prefix is deleted from the Kube API, don't delete it in NetBox. And we also have a prefix length of /32, which is basically the equivalent of an IP address, so we can ensure sticky IP addresses by using exactly that feature. So I will now apply these resources and see if we get something there. So we now have 3 prefixes. You can see sample 1 has prefix 0, sample 2 has prefix 1, sample 3 has prefix 2. So nothing special here. Let's delete these prefixes. I will do that based on I will delete the entire namespace. And now I will create these resources in reverse order to prove that we don't rely on the order, we just rely on something else. So when I create the first one, we do have some lease problems sometimes, so I will delete these leases now, which should hopefully speed up things. So when I create the third prefix now, this will show you that we've successfully restored the same prefix. I will do the same with the second and first, and we should be able to see that we've actually restored the same prefixes. This is done based on a restoration hash that we compute based on the immutable fields of the prefix claim. And the reason why we do that is because some applications, especially telco applications, they need sticky IPs because you have IP addresses in configurations. And if we use a dynamic system like that, we would really like to avoid changing IP addresses too often. For instance, you configure an IP address of some core component in your RAN, which will lead to thousands of updates and probably also downtime. So that's why we created this restoration feature in NetBox Operator. So that concludes our demo. We have 2 more demos in the Git repo. One is about prefix exhaustion, which basically allows you to, based on this dynamic selection process, to exhaust prefixes. But if you automate it the correct way, then we can overcome that. And the other one is multi-cluster support. So we support consuming NetBox from multiple clusters. I will come back to this productivity slide again, because now we see on the right side what we've gained. So what we've shown in these demos is basically some examples. We don't show the entire process of how we use NetBox Operator, but we really think that we can, by using NetBox Operator, by using KRM, we can really reduce our effort spent for provisioning from days and weeks down to minutes and hours. So that's why we're doing this, and that's basically the success story of this KRM approach. With that, I will talk about some of the use cases. So you've seen the MetalLB case shown by Leah. That's basically including the, so we extend that with the entire fabric configuration, like the cluster bootstrapping process. Another use case is the 5G core network function configurations, day 0 and day 1. There we need this sticky IP feature. And the third use case that another team in Swisscom is working on is the VNF configuration. Then what's coming up next? So we have a few things. We will certainly expand or explore more use cases. We will discuss the potential usage in Project Silva. That would certainly be interesting. We will work on enhancements of NetBox Operator, be it features or stability, and then we will evaluate or continue evaluating tools like KCP or KRO. You have seen KRO in Leah's demo, and we will continue to do that. And with that, I ask you, if you're using NetBox in your system, please get started now by using the NetBox Operator. Give it a try. Have a look how it works, how it can suit you. And for sure, automate your infrastructure using KRM, similar to what Kubernetes is doing. Please have a look at these projects. We really think that's the way to go forward in the industry. On this slide, you can find the QR codes to the NetBox Operator Git repo on the left side, and on the right side you can find these slides and the feedback form. And with that, thanks a lot for being here. Thanks a lot for your interest. It was a pleasure, and I think we do have 3 minutes for question. Does anyone have a question? I don't know how it works here. Okay. Then thanks a lot. Enjoy the rest of the day. See you around.